This video is for the first knowledge organiser on direct proportion. What I would like you to do is read your knowledge organiser, watch this video and go through the examples from page 1, try the questions from page 2 of your knowledge organiser, and complete any maths watchwork set. So if we have a look at what our knowledge organiser says, it says two quantities are directly proportional if they are always in the same ratio. Okay, this can be written as a proportionality statement. Now that means that this here is our symbol for proportional to. Okay, so P is proportional to L, which is read as P is proportional to L, or P varies directly as L, or P varies as L. You're going to see one of these statements in the beginning of the question that tells you it's a direct proportion question. Okay, when you do that, we're going to write an equation for it. So if we have a look for this one here where it said P is proportional to L, that means P equals KL, and K is called our constant of proportionality. Okay, graph of a proportional relationship is a straight line through the origin, similar to what we've done here, and the gradient of the graph is equal to the constant of proportionality. So basically, that value of K, that is our gradient. Okay, you use this as well in science, so you may have seen this in science. Okay, what we're going to do today is we're going to look at forming the equation for proportionality, and we're going to use that to find missing values. Okay, so there's two different ways you can be given direct proportion. Okay, the first way is in a table, the other way is through an equation where you're given two different values and you have to work out the equation from that. So I'm going to start off with the table first. So it says y is directly proportional to x, fill in the gaps in the table. It doesn't specifically ask you to work out the equation of proportionality, but or an equation for proportion, but what you need to do to get your first mark in any of these questions is to write a proportionality statement. Okay, so you can either write, in this case, y is directly proportional to x like that, or you also get your mark for writing y equals kx. Now I tend to personally write this mark here. Okay, write this line here as opposed to writing this. You can write both, you'll get the same 1 mark for it, but personally I use this because this is what I'm going to use to solve for values of x and define k. Okay, when you've got your direct proportion in a table, if you have a look, you've gone from 10 to 25. Your value of k, what it's being times by, is what 10's been times by to get to 25. So to find out what k equals, we can do 25 divided by 10 equals 2.5. Okay, and that's all we have to do for that. And then we can say, right, what happens to each of these numbers as they're times by 25 to go that way, or divided by 2.5 to go that way. Okay, I meant times by 2.5 there, if that sounded like 25. So what we do is we do 3 times 2.5, which gives us 7.5. We do 5 times 2.5, which gives us 12.5. Notice there's a relationship here. 5's half of 10, so 25. If you half that, you should get your 12.5 there. Okay. The same goes here, that 3 times 4 gives us 12. We could do 7.5 times 4 and that will give us our value. Or 12 times 2.5 gives us 30. And when we're going the other way, we do 100 divided by 2.5 and that gives us 40. Okay, now in many ways that's easier. If we were to make sure we wrote our equation out, our equation for this proportion would be y equals 2.5x. Okay, now in a table, as I said, it can be quite straightforward. It's many ways easier than the other way of doing it. When we have this problem here which says m is directly proportional to e, given that m equals 72 and e equals 6, you then have to use this to find the constant of proportionality and then to substitute in to find that. So what you're going to do is you're going to start off by writing m is proportional to e and then m equals k e. Okay, and then what we do is we substitute in the values that we're given. So we're given m equals 72. We're told that e equals 6. So what we do is we say 72 equals k times 6. And then we find out that 72 divided by 6 equals k. So therefore, if I just write this the other way around, k equals 12. That's all we have to do for it at this point. If we wanted, we could put that back into this equation up here, which would give us m equals 12e. And that's what we're going to use for our next part. Okay. For our next part, we're asked to calculate the value of e when m equals 37. So all we do is we take our equation that I've just wrote, which is m equals 12e, and then I substitute in the value that I'm given. So I'm told m equals 37, so I say 37 equals 12e. To work out e, I just divide by 12, so I do 37 divided by e. Again, I can write that the other way around now at this point, and what comes out when I do that would be 3.08 to 2 decimal places. Okay, and that's all I have to do. Say I was asked to find out the value of m when e equals 10. Okay, all I would have to do is again start with my formula, which is m equals 12e. Substitute e equals 10. So m equals 12 times 10, and then m would equal 120. Okay, so in this case there's a bit of rearrangement to do, but if you're asked to find the value of e, the value of the algebraic term that's on the same side as your k, you're just going to multiply. Okay, use this video to complete the questions on page 2 of your knowledge organiser. Thank you. And any maths watch work set by a class teacher.